So certain things are undeniable. One of them being that you would interact with water every single day of your life. Sure, you can decide to go a whole week without drinking water, and good luck for doing that. But you probably would walk or run and maybe break a sweat, and that is water in of itself. But we never truly interrogate the water that we come into contact with, the one we pour down our system and the one we pour away from our system, as to whether it is clean or whether it is something that is very good for use. And that is what the slides is going to basically be about. Wastewater treatment. It's going to be a comprehensive overview, of every single thing you need to know about the purification of water. So the stages of wastewater treatment, they come in 4 stages. Excuse me if I butcher some of the words, because they are hard to pronounce. They are a bit of tongue twisters. Preliminary treatments, that's the first one. Second one is primary treatment. Third one is secondary treatment, and fourth one is tertiary treatment. So let's start with the preliminary treatment. So there are two important things you need to note about this stage. The first one has to do with screening, and this basically has to do with you removing the huge impurities that are in the water. So things like rocks, sticks, plastics, the obvious things that you can really see with your eyes when you look at the water. You want to remove all of those things. The second thing is grit removal. After you're done screening, the wastewater flows through a grit chamber. And what happens here is that the heavier particles, like the sand, the gravel, the grit, they settle to the bottom. The reason why you want them to settle to the bottom is because you want to make sure that these abrasive materials do not wear and tear down your machine, to make sure that they don't clog your pipes. And the reason why these 2 stages, as part of the preliminary treatment, are very important stages is because they are going to be the pace setters for the next stages to come. That is to say, you want to remove the big materials before you start removing the small materials. It makes things much more easier that way. Let's move to the next stage, and that's the primary treatment. So 2 things to note. The first one has to do with sedimentation. And what you do during this stage is that you slow down the water. And the idea is to make sure that all the solids that you could not screen out, they settle to the bottom. And what they do is that when they settle to the bottom, they form a sludge. So what you can then do is that you can scoop the sludge out, you can remove the sludge from the water. But then it's not every single one that will settle to the bottom, because for it to settle to the bottom, it probably has to have a very high density. What about the ones that have low density and can float on the water? That is where skimming comes in. So you fetch out the floating parts, the floating impurities that you don't want. Oil, grease, you try to remove them from the surface of the water. And you can achieve this by using mechanical skimmer that essentially collects the floating materials and removes them from the wastewater. Again, why is this primary treatment important? It is important because it makes the next stage equally easier. That is the secondary treatment, because when you do this part, everything gets much more smoother as you proceed. What then is the secondary treatment? And 2 things that you have to really recognize. The first one has to do with activated sludge process. And in this process, the wastewater is mixed with a concentrated suspension of microorganisms. And this might sound weird for you, because we want to make the water pure. Why then are we introducing microorganisms? Now, this concentrated suspension of microorganisms is called activated sludge, and it is put in an aeration tank. The reason for this is that you want these microorganisms to consume the organic matter in the wastewater. Mind you, you could not remove everything, but there are some of the things that you can remove them when organisms have consumed them, like these organisms want the organic matter because they use them for their own biological processes. So what you want to do is that you want to introduce them. But then along the line, we would eventually kill them. So the second thing is trickling filters, and trickling filters are a biological treatment process where wastewater is distributed over a bed of media. So it could be rock, it could be plastic, could be, yeah, it could be any of these two. And the wastewater trickles through the media. The microorganisms consume the organic matter, removing it from the wastewater. But then also lagoons. They are large, shallow ponds where wastewater is treated through a combination of sunlight, bacteria, and algae. Sunlight promotes the growth of algae, which consume nutrients in the wastewater, while the bacteria break down organic matter. The lagoon systems are often used in areas with large land availability and suitable climate conditions. Let's move to the next treatment stage, and that is the tertiary treatment. So, three things that you have to recognize. One is advanced filtration. And with advanced filtration, what we want to do is that we want to remove the finer particles. So we started with stages that were removing heavier particles, that are like bigger particles. But now we want smaller particles, like way finer particles to be removed. And we use the advanced filtration for that. In order to do this, specific things that are used are sand filters, activated carbons, or membranes. But the second thing then to note is nutrient removal. You might think maybe nutrients are good for our body all the time, and it's only intuitive to want much more nutrients in water. Well, sometimes these nutrients are not really the best, because as much as they might be good for human beings, they are equally good for other organisms, meaning that their presence will cause their growth, making the water unsafe to drink or unsafe to use. So you want to remove nutrients in these instances, and that is what the tertiary treatment equally is about. And in order to do this, you typically involve the removal of nitrogen and phosphorus by using biological, chemical, or physical methods. Remember I told you about how we are going to kill organisms, right? This is where we kill organisms, and it is a part of the tertiary treatment. And you want to remove these organisms because all the other stages that we utilized could not remove these microscopic organisms, because you can't fetch them out with machines because they are very, very tiny. It means you need to kill them. And the way you can kill them is by chlorination, ozonation, ultraviolet light irradiation to, shine the light on them and kill them and make sure that they are unalive and we can have safe water. So let's look at something called the sludge treatment. And four things you need to note initially for this, right? The first is thickening. Now, sludge thickening involves concentrating the sludge to reduce its volume and make it easier to handle and dispose of. This is typically achieved using gravity settling or mechanical thickening. The second thing is digestion. Sludge digestion is a process where microorganisms, what they do is that they break down the organic matter in the sludge, then they produce biogas in the process, right? The process can be carried out aerobically or anaerobically, depending on the available oxygen and then the desired outcome. The third thing is dewatering. So sludge dewatering is the process of removing water from the sludge to produce a solid cake that can be easily handled and disposed of. The fourth thing is disposal, and that is you want to like throw the sludge away, right? So the final step in sludge treatment disposal is like the treated sludge can be landfilled, used as fertilizer, or incinerated, depending on the type of regulations that are existent in the place. Some of them might want to protect the environment so highly because of like very, very good reasons, so you cannot do certain things like incineration. You would have to use it as fertilizer. So depending on the type of place you find yourself in, you tune your disposal technique to it. Now let's look at the wastewater treatment plant design. So let's first take a look at the population saved. Now, the size of the population saved determines the capacity of the treatment plant. Obviously, what this means is that if you are catering to a big population, you obviously need a bigger wastewater treatment plant. And this is just to let you know what goes into designing this wastewater treatment plant. The second thing then is wastewater characteristics. So the type and amount of contaminants in the wastewater would influence the level of treatment you would give to the water. Site topography, the layout, the topography of the site affects the way in which you are going to be putting out your design. The fourth thing is environmental regulations. Obviously, you would want to conform to the laws because you don't want to go to prison. Maybe you do, but the average person would not want to go to prison. So you would have to conform to environmental regulations. And in order to be able to do that, there might be specific things that they would want you to use, or specific parts of machines that they would not want you to use. Maybe they would want you to use renewable technology in producing your energy and etc. Then the final thing is that maybe you know all of these things, but maybe you don't have money. So you just design according to your budget. That is to say, it must be effective in the treatment process, and it must still be within the confines of the cost of production and operation. Now let's look at physical treatment methods. I think we've spoken a lot about it: screening and filtration, sedimentation and flotation. Screening, you are removing big things, right? And you are filtering, you are removing suspended solids from the wastewater. Sedimentation, you want to employ the laws of physics, that is gravity. The more dense you can sediment, less dense will probably float, and then you would scoop them out in that regard. So now let's take a look at biological treatment methods. So aerobic and anaerobic processes. Activated sludge and biofilters utilize aerobic bacteria to degrade organic matter in the presence of oxygen. That is for aerobic process. But for anaerobic process, anaerobic digestion systems decompose organic matter in the absence of oxygen producing biogas. Now, chemical treatment methods. So first of all, let's take a look at coagulation and floccu. Excuse me once again if I butcher any word. Flocculation. Chemicals like alum or ferric chloride aggregate fine particles into larger clumps for easier removal. There is chemical precipitation, and that is dissolved substances are removed by forming insoluble compounds that precipitate out of the water. The third thing then is oxidation. Chemicals like chlorine or ozone oxide chemicals like chlorine or ozone oxidize and break down pollutants, making them less harmful. So membrane technologies. So recognize we are just getting much more into the terms that I stated earlier, or specific terms that I didn't really explain. So membrane technologies is one of the things that we saw as an example of one of the technologies used in the filtration process. So microfiltration and ultrafiltration. These membranes remove particles, bacteria, and some viruses from wastewater. Nanofiltration and reserve osmosis. These advanced membranes remove dissolved salts, organic molecules, and other contaminants. What are some of the emerging technologies that we have to note whenever we are talking about wastewater treatment? The first is electrocoagulation, and this method is basically you want to remove contaminants from wastewater, but you are employing the use of electrical current. The second one is advanced oxidation processes, or AOPs, and they utilize hydroxyl radicals to oxidize and break down pollutants. The final thing is constructed wetlands. These systems mimic natural wetlands using plant, soil, and microbial activity to treat wastewater. Well, we have spoken about sludge treatment and disposal. So, environmental and regulatory aspects. Of course, the environment is very important. It is what we are going to leave our future generation to. So we can't talk about something like this without talking about environmental implications or anything in relation to that. So recognize that there are regulations and standards. Wastewater treatment is governed by local, national, and international regulations to protect water quality, because water is very important, as I stated from the beginning. The environmental impact is that proper treatment minimizes pollution of rivers, lakes, and oceans, reducing risk of public health and ecosystems. I mean, the fishes will be in the water, they will probably die if we have galamsey colored waters. So, what we want to do is that we want to make sure that the environment overall is safe because of the wastewater treatments that we do. Now, sustainability and resource recovery, energy efficiency, resource recovery. So, the wastewater treatment facilities are increasingly adopting energy efficient processes and renewable energy integration, because as much as we want to make the environment clean by making our water clean, we don't want to end up hurting the environment in that process. So it means that we must make sure that the energy is efficient. The second is resource recovery. Technologies are being developed to recover valuable resources like water, nutrients, and energy from wastewater. And that ends everything. Thank you.